So uh, let's do an example so that we have a better understanding of what we have discussed as of now. There are five situations, five investments here. We have five investments. The maturity and the liquidity, along with the default risk, and all these situations are actually the interest rate. These have formed the interest rate for these conditions. So here the maturity is 1 year for investment one and two. Maturity is 2 year for investment C and maturity is 3 years for investment D and E. Liquidity is high here, liquidity is low here, and liquidity is again high and low. High liquidity is favorable for us and low liquidity is not favorable for us. Default risk is low here, which is favorable for an investor, and default risk is high, so that's not favorable for an investor. Along when the maturity increases, so does the interest rate also increases. And how do we calculate the maturity, the premium for maturity? So here I have uh, put this example right below the formula so that we are able to relate to what we have learned as of now. So these are the factors. So for one, if the time horizon is same, so premium for maturity should also be same. Okay. So the first question here that we actually have to answer based on this table is difference between interest rates on investment A and B. So if we look at the table carefully, so we will see that difference is because of high liquidity and low liquidity, because the time horizon is same, the maturity premium is same for both of these. And in between investment number one and two, the difference is because of high liquidity and low liquidity. So for liquidity, I can say the premium liquidity premium for 1 year. The liquidity premium for 1 year is 2.5 minus 2.0, which could be 0.5% based on this data. And based on this data, if the liquidity premium is okay, the default risk premium, sorry, not the liquidity premium, but the default risk and the high liquidity. So default risk and liquidity, the liquidity for liquidity, we can say that there is a difference of 0.5. And when we talk about question number two, estimate the default risk premium. For that, we actually have to look at an investment where the default risk is different, and the liquidity is also different. Here we have made an assumption using question number one that because of liquidity, there is a increase of premium by 0.5%. So in second example, when we are estimating the default risk premium, we are going to use the same thing here also. So I'm going to assume that this uh, I'm going to consider investment D and E for this default risk premium calculation because they have the same maturity. The maturity is same here, but but different liquidity and different default risk. So uh, let's try to make liquidity similar because we actually have a liquidity premium of 0.5, and if the liquidity is low, there is going to be a premium of 0.5. And we can use that, or we can use that because of high liquidity, there could be a premium of 0.5. So what I'm going to do is I'm going to adjust this and I'm going to say that because this is highly liquid, so this means that the interest rate is because of high liquidity, the interest rate is 3%. But if it was low liquidity, So interest rate, there would have been an extra premium of 0.5%. So this will make it 3.5%. So now I'm going to compare it based on the liquidity default risk, because now I have made this also low liquidity. Liquidity, I have adjusted for liquidity. That maturity, the maturity is already 3 years. Now I will be able to calculate the premium for default risk. Now, given this data, I hope you are able to understand what I'm trying to convey here. Now, given on this data, I would say default risk premium, default risk for a high investment, I mean, for default risk, I want a premium of 0.5% again, because 4% and 3.5%, there is a difference of 5%, 0.5% only. So this is going to be my premium for default. If the default is high, I want a premium of 0.5%. Now, understand this thing. If the default is high, the premium is 0.5. If the liquidity is high, if the liquidity is low, the premium is 0.5. Low liquidity, 0.5. I want premium of 0.5, and for high default, I want a premium of 0.5% in both the cases. Now notice the difference between B and C. So there is a difference. Now notice the difference between B and C. If you look at the investment for B and C, there is the liquidity is low. So this is same, and default risk is also low. Now, how much should a investor pay for the maturity in years? So after 1 year, there is a probability, there is a po- there, I mean, there is a possibility the interest rate of C might be higher than B. So the interest rate is 2.5, because there is a factor of time. And if you compare these numbers, let me just remove these numbers, remove the calculation first here. I will keep the findings of uh, when the findings of question number 1 and 2 here only. When you compare 1 and 2, this is low, this is low, this is comparable. So there should be I mean, this should be higher because of extra maturity. It should be more than 2.5. It should be more than 2.5, this number. And another situation, another comparison that we should make here is that default is low, liquidity is low. Default is low and liquidity is also low. Rather than comparing this thing, let's compare investment C and E. So here the liquidity is low and the default is low and high. For low liquidity and high default, for low liquidity and high default, when we look at this, uh, or let's compare C and D. So if we look at this, the default is low. This means this is a good thing. But when we talk about liquidity, so liquidity here is low and here liquidity is high. Here the liquidity is high. So I can say that this R, this rate, if I give it, if I adjust this and I make this low again for comparability, so I will actually have to add 0.5% here. This is our actually the liquidity premium, 3.5. So the value of R, our the interest rate that we are trying to find, it should be in between 3.5 to 2.5%. We're not sure about what it should be, but this is the range that upper and lower limit for the interest rate uh, in for investment C and the rate R. So this is actually where we have used our analytics, where we have used our analytical mind to come across to understand what should be the answer for this situation. I hope this much is clear. Yes, this is tricky, and it is supposed to be tricky, but you will be able to figure out once you start thinking in a practical way, in a practical manner. So, okay, let's do some questions. Some questions. So, question number one. So, question number one is about the real risk-free rate that can be thought of. What do you think of real risk-free rate? So, real risk-free rate is something that real risk-free rate is something that do not consider inflation. So, if you look at the options, reduced by the expected inflation, option C, reduced by expected inflation, option B, and risk-free rate plus expected inflation. So this is already wrong because we know that real risk-free rate do not have inflation in it. So option number A is already wrong. But is it exact or is it approximate? Then that's the question. So real risk-free rate is actually an approximately, it's the nominal risk-free rate reduced by expected inflation. So approximate relationship between nominal rates, real rates, and expected inflations can be written as this equation. Nominal risk-free rate is equals to real risk-free rate plus expected inflation. And we can rewrite this by moving risk-free rate here. And we can say that nominal risk-free rate, we can subtract the expected inflation. So that's the equation here. And the exact relationship is this, the above one. So 1 plus nominal risk-free rate is equals to 1 plus risk-free rate into 1 plus expected inflation. All right. So let's move to question number two. So question number two is asking us about the T-bill yield. T-bill is treasury bill. Yield is something which we use in bonds. So uh, rate yield also represent rates. So T-bill yield, T-bill rate, treasury bill rate in simpler terms can be thought of as what should be a treasury bill yield, treasury bill rate can be thought of as. We have three options. Let's start from option C, real risk-free rate because they contain an inflation premium, but the treasury bill yield, that's something when we discussed about the treasury bill yield. Treasury bills are those bills which are used as a reference for real risk-free rate. So they do not contain inflation, they do not contain default risk premium, not liquidity, not maturity. So coming back to our question, so real risk-free rate because they contain inflation premium. So real risk-free rate do not contain inflation premium. No, this is wrong. Nominal risk-free rate because they do not contain inflation premium. Now, nominal risk-free rate do contain inflation premium. Nominal risk-free rate. When you talk about nominal risk-free rate, it has the impact of inflation. And if we are talking about nominal risk-free rate, please assume that interest inflation is already factored in. I'm saying that the nominal risk-free rate is 5%. This means that let's say 1% or 2% of inflation is already added into that. So that's what I mean to say. So they actually have factored in for inflation. So this is also wrong. Now we have option A. So nominal risk-free rate because they contain an inflation premium. T-bills be thought of as yes, nominal risk-free rate because they contain an inflation premium. So nominal risk-free rate contains inflation premium, do not contain inflation premium. Risk-free rate because they contain inflation premium. So out of all these three, A is the right answer. CFA exam, uh, it's not very calculative in nature. So the testing is also done on uh, uh, these kind of questions where they do not have anything to calculate, but theory, based on theory also, they actually test you. And 40% on calculation and 60% on theory, and at times it's different also. But the concept clarity, the not even 40%, but lesser than that. At times, I'm not very sure. That's just I'm just making an assumption here. But yes, if you look at the previous year, if you are able to find the previous year's candidates who have appeared for those exams, uh, you can discuss with them. The theory part is not that much, just because they are, sorry, the theory part is there. The calculation part is not that much, just because they have recommended you use a calculator. Calculator is only helpful for calculations, but the logic behind everything is based on theory. So that's why you actually have to pay attention. So whenever you prepare yourself, whenever you start preparing yourself for CFA exam. Okay, question number three is which of the following return measure is best described as purely representing time preference? Time preference. Yes, we discussed about time preference. In time preference, we talked about time preference when we discussed about real risk-free rate of return, real risk-free rate of interest. So it represents in economic terms time preference, the degree to which consumption is preferred to equal future consumption. So question number three is about which of the following return measure is best is describing as time preference, and then the answer to this is real risk-free interest rate. So real risk-free, nominal risk-free, total rate of return. You should be able to answer these. The conceptual clarity should be there now by then by now. So the real risk-free rate interest rate represent the time preference or the degree to which the consumers prefer consumption in the present to an equal amount of consumptions in the future. And other measure of return include time preferences here. But it also reflects other factors such as risk and expected inflation. So here the expected inflation is factored in, and other risk, liquidity, maturity, default, everything else is inflation is in the it's factored in the total rate of return. Now let's move to next question. So there is an analyst, Weijiang, uh, has funds on deposits with Iron Range Bank. The funds are currently earning 6% interest. If he withdraws 15,000 to purchase an automobile, the 6% interest rate can be best thought of as an or as a. Here, if you look at the situation, so here the analyst or the person here, Vizan, he is actually foregoing interest on by withdrawing the funds. The 6% interest rates, this 6% interest rate. If you say that this is a discount rate, yes, this is a discount rate. financing cost. This is the financing cost. We are not talking about the financing cost anywhere. We have not discussed about financing cost. Discount rate could be right. But here, if you look at the scenario what they are talking about, this is representing disk opportunity cost. So here he is foregoing, uh, he's letting go of the interest he's going to earn on his investment, and he is actually consuming this thing. By buying an automobile, he's consuming this $15,000, and so this return, if he could earn by postponing his auto purchase until future, he's not doing that, but he is consuming this $15,000. So this is an example of this actually is representing opportunity cost here. So best thought of as an opportunity cost. So this example is talking about, this question is actually talking about an opportunity cost. Okay, so now let's move to uh, question number 5. So there's a person, Susie Jones, has just inherited some money and wants to get some of it aside for a vacation in Hawaii 1 year from today. His bank will pay him 5% interest on any funds he deposits. In order to determine how much money must be set aside and help for the trip, he should use 5% interest rate as what? Here we are talking about XYZ amount of money, and they actually are saying that they want XYZ plus some surplus from interest rate. So he is actually planning a vacation 1 year from now. So within 1 year, how much should he earn? He should use 5% as what? So 5% is going to be used as a discount rate because he's actually planning to consume this thing. Opportunity cost cannot be the option. Required rate of return, because we are not comparing something. So unless until we are comparing something, it's a discount rate. And yes, we discussed that compounding and discounting. So that concept doesn't apply here. Discounting rate is simply referring as interest rate. And that's what they're asking. 5% should be considered as the interest rate. So he needs to figure out how much the trip will cost in 1 year and then use 5% as the discount rate to convert the future cost to the present value. So this is how, that's why it's the best fit for this example is discount rate. Okay, question number 6. Question number 6 is, here we are talking about Vegas Research. So Vegas Research has been conducting investor polls for the third state bank, and they have found that most investors are not willing to tie up their money in a 1 year or 2 year CDs, collateral deposit, unless they receive at least 1% or 1.5% more than they would on an ordinary saving account. So now understand the context here. So collateralized deposits, these are special type of investment vehicles. More, they actually investors want more, 1 to 1.5% more for 1 to 2 year. For 1 year and 2 year, they want 1% more, and for 2 years, they want 1.5% more than an ordinary saving bank account. So ordinary saving accounts, if the saving account interest rate is 3% and the saving account interest rate is 3%, the bank want to raise funds with 2 year CDs. They must yield, I mean, the yield must be at least, so the saving bank account rate is 3%, and simply we can calculate this because 2 year CD, the interest rate is 1.5%, and the investors who actually want 4.5%. But we have two options where the investors are actually uh, I mean, these are two options where they are saying 4.5%. But now understand this thing, since we are taking the view of the minimum amount required to induce investors to lend money, lend fund to the bank, this is best described as the required rate of return based on the numerical information. So this is actually not a discount rate, but here this could go above this. This could go above. So they are actually, unless until they receive, then they have found, if you look at the situation, unless until they receive. So they could, there could be it could be more than 4.5%, and at least it should be more than 5%, not 4%. So for 2 years. But if they talked about 1 year, so then yes, 4% would have made more sense for 1 year. But for 2 years, it should be 4.5, and here it's representing the required rate of return. So example A, and this is actually a very good example, and you actually have to pay attention to these theoretical questions. So this is how actually CFA Institute test your knowledge based on the learning outcomes. So if you have attended the lecture, this LOS, the very first lecture, so you have understood that this is not going to be an easy task to clear your CFA exam. So you need to have crystal clarity with your concepts. Now let's move to question number 7. So, question number 7 is, which one of the following statement is best describes the component of the required interest rate on a security? So, required interest rate on the security, and we have options: real risk-free rate, the expected inflation rate, default risk premium, liquidity premium, premium to reflect the risk associated with maturity of the security. Yes. Nominal risk-free rate, nominal risk-free rate, expected inflation rate. Okay. So nominal risk-free rate already does have expected inflation, right? So if nominal, we are all calculating, again adding in expected inflation. So this means we are double calculating. So this is the wrong option. Default risk premium, that's right. Liquidity premium, that's right. Premium to reflect risk associated with maturity, that's right. But if you are using double inflation, then this is wrong. That's why real risk-free rate. Okay, so real risk-free rate doesn't include uh, expected inflation. Real risk-free rate, default, liquidity, premium to associated with maturity, but they have missed the inflation here. So that's why this option is also wrong. Let's see option number A. So the risk-free rate is there, expected inflation is there. Risk-free rate, expected inflation, default, liquidity, premium to reflect the risk associated with maturity of the security, and exactly this is what they have asked in the question. Risk-free rate, inflation, default, liquidity, maturity. The risk-free rate, inflation, default, liquidity, and maturity. So that's why option number A is correct for this answer. Is the right answer for this example. So the required interest rate on a security is made up of nominal rate, which is in turn made up of real risk-free rate plus the expected inflation rate, and it should also contain a liquidity premium as well as the premium related to the maturity of the security. Right, so that's it for today. So tomorrow, in the next session, we are going to discuss about LOS 1B, calculate and interpret different approaches to return measurement over time and describe their appropriate uses. All right, so that's going to be our next LOS. Thank you for attending this session.